So yes, to just recap everything since this is recording here, your online homework due on this coming weekend, this coming Monday midnight will be 2.5, 2.6, and 2.7. We will talk 2.6 and 2.7 today in class. So if you guys have any questions you have, please either ask me now or type in the chat room what questions we have. I am going to do 2.5 question 16 because someone asked this question and I will have to teach you guys how to do this so you guys will get it. So if you guys have any questions, do not be shy to ask questions because you pay for this class. So you pay for it, you ask me any questions, then I will help you. Okay. If you are shy, you want to, then stay back after class and I will help you after class so that I will record this whole thing. So we're going to talk about these three sections here, 2.5 question number, 16. Okay. So this is 2.5 question 16 where they ask you to write equations for the function. It is x squared and then it shifted 7 units to the left, 8 units up and reflected on the x-axis. So this is how you will have to do it in how we do this question. When you move 7 units to the left, you take the x squared and you make it as x plus 7 squared. So the plus 7 means you move it to the left 7. And then when you make 8 units up, you add 8 at the back. Up 8 units means you take x plus 7 squared plus 8. And then when you reflect on the x-axis, this is something that I, as a teacher, will not agree on it. Usually you just put a negative in front, but for this case, you have to put a negative and a brackets. Brackets is like parentheses because we have parentheses there, so we just use a bracket. And then you have to distribute the negative. So in this case, you have to distribute the negative to x plus 7 squared and 8. So the negative will go to x plus 7 squared, and then the positive 8 become negative. So this is your answer for question number 16. How do we do this kind of work? So a lot of students did not distribute the negative on it. They will mark it wrong, which I am totally agree with you and disagree with the way that they do it. So I don't know why that they have to distribute the negative. Usually you don't, you just put a negative in front. So, so this is how we do question 2.5, question 16. Does any one of you have any questions before we start the class here? Homework questions, any questions you have for me? Anyone? Before we start the class today? All right, so if you do, just let me know and then I will talk about it. So today we'll talk about 2.6, which is composite functions, and then 2.7, the inverse function. And once we finish 2.7, that is the end of chapter 2. 2.7 is the last section. Now, I also want to point out about homework. I know some of you have waiting for this and waiting for that and coming in late. I can only extend your homework one time. And I can only do it so some of you are asking for extension because they forgot to do the homework or some reasons behind it. Then I will extend it for you only one time. So the next time when you ask for it, I will deny the request. So do not forget, I also dropped 2 of the lowest online homework. So that's the reason why that please make sure that you guys do your homework here. This coming week, you got 3 sections. Make sure you guys do it. Okay, so let's talk about combination functions here. So combination functions is where you take 2 functions and you combine them. So one is called, we can add them up, we can subtract, we can multiply, and we can divide. Okay, so the only you just add 2 functions. So when you find the difference or the minus it, make sure you watch out to distribute the negative. Okay, so so when you guys do the difference of functions, this negative you have to distribute to the gx. Okay, so make sure you distribute the negative to gx. A lot of students did not distribute the negative. They get it wrong. Product is when you multiply it, and usually you have to void when you do this. Quotient, you just divide it. Now, when you do quotient, when you divide it, make sure that in order for you to cancel something else, you have to factor first, and then you cancel out the common factor. So what do I mean by factor first and cancel by common factor is something like this. So 2x plus 1 divided by, let's say, 4x squared plus 1. So a lot of students, they just say, oh, 2x and 4x I can reduce. 1 and 1 I can reduce, like 1 and 1 you can cancel. And then 2x and 4x squared I also can cancel, become 2x. And then my answer is 1 over 2x. That is wrong. So why it's wrong is because you cannot cancel fraction like this if you have addition or subtractions in a term like this. You can only cancel them if they have a common factor. So what do you need to do in this case is you have to factor it. So what you do is 2x plus 1 is, that's it, you cannot factor it. But 4x squared, not plus 1, 4x squared minus 1, sorry. So 4x squared minus 1, you can actually factor it to become 2x plus 1 and 2x minus 1. And now you can cancel the 2x plus 1, and that will give you 1 over, so the 2x plus 1 can cancel, then you get 1 over 2x minus 1. So this is a correct way to do this. So make sure you guys know that when you have a division, you have to factor first, then you cancel the common factor. And then this case, you have to watch out for the domain. Because the domain here is your denominator cannot equal to 0. So in this case, your domain will be all real numbers, except, anyone know what number it cannot be? Again, your domain is special here. So domain is all real numbers, except what?
1.
What? Elijah?
1.
Not 1. This is 2x minus 1 down here. This is not 2. This is 2x minus 1, not x minus 1. Why is 2x minus 1 when you make it equal to 0?
1 over 2.
1 half.
Half.
Yes, 1 over 2.
Yeah.
Yes, you're correct. So so make sure you guys understand that when you guys do, so that's why you see the gx cannot equal to 0 is because the domain issue here. So make sure that this is how you divide. So the quotient here. So make sure that you guys understand this very important stuff before you guys move on. So this is very easy. The next one is composition functions. Composition function is like where you put the input of the output of the functions go back to the input of the second functions. So we use the dot, the big dot. So f dot g of x. So so when you have f dot g of x, you start from g of x. So you put something into the g of x, the output you go back to the f. So for example is this is g dot f. I switch around. So if you have g dot f, that means the input of the f functions, you put a number in, you get an output. The output will go into the input of g, and then the answer will come out in the output of g. So this is g dot f, means you do the f first, then the g. So how do you know which one you have to go through first? Is you have to do the last one. So if f come last, you do it last. If g come last, you do it first. Sorry, if g come last, you do it first. Okay. Then we talk about the domain. So how do you figure out the domain here is this is very important. The domain of this f dot g can be found by doing this. The domain of f dot g, that means this whole thing together, and the domain of f. So when you guys do the f dot g, you have to figure out two domains here. One domain is the whole f dot g, and the other domain is f domain, the function f. But if you do a g dot f, the domain is the domain of g dot f plus the domain of G. I will show to you what do I mean by that, because it's kind of like confusing, right? What's going on here? So let me show to you right now so you guys know what I'm talking about in this dot product here. So let's say that you got your f of x is x squared plus 1. And the g of x is the absolute value, g of x, no, not the absolute. Let's do 1 over 3x. 1 over x, make it simple. So how do we find the f dot g here? So in order for us to do the f dot g means you start from the g, like substitution. You take all this g and you plug it into your x here. It's like substitution. So if you do f dot g, you take all this g, plug it into that. So in this case, it will become 1 over x squared plus 1. So this is the f dot g, means you take all this, plug it over that. And now you have to figure out the domain in this case. So how do you figure out your domain in this case is you have to figure out the domain of this and the domain of f. Because f is at the first here, so you have to figure out. The good news about the domain of f is it is all real numbers. Because when you have x squared, it is all real. So domains, when you have domains, all real numbers means any numbers goes in there. But when you look at the domain of f dot g, it's not all real numbers, it's because it has a fraction. And as you guys know that any number you plug in here, you have to avoid 0, right? Like the other example. So your domain in this case will be all real numbers, except what? You want to know what makes this become 0 in the denominator? This is very straightforward. This is easy. Do you guys hear me, right? So what do you guys think? All real, if this domain is all real numbers, except what? What makes this 0? I will give you the answer already.
1.
No, 1
2
doesn't.
plus
This
x squared plus
1 over x squared.
x.
1 over x here. What's the domain here? What will make him no good? The denominator. It will be 0. Because 1 over 0 is undefined. So the domain in this case is all real numbers except 0. Okay. So make sure you guys, this is something that you need to watch out for here. Now we do g dot f. Now what happens when you do g dot f is you have to do the opposite now. So what do I mean by opposite now is you take all this f of x, because f is at the end here, and you have to plug it into your x on the g. So in this case, this will be 1 over by x squared plus 1. Okay, so 1 over x squared plus 1 because you plug all this into here. Now you have to figure out the domain of this g dot f. So first thing is we have to figure out the domain of g because it is the g come first. So what is the domain of 1 over x? Anyone? What's the domain? What will make him undefined or did not exist? All real numbers except 0. Very good. That's correct. Which is exactly the same as the one that we just did just now, because that will make him undefined, right? But if you look at this domain is the very special case because usually when you do domain, you set the denominator equals to 0. Like remember last time when we do this example here, how do we get 1/2? We take 2x minus 1 equals to 0 and solve for it, right? So this is the same type of questions that we will have here is we take the x squared plus 1, make it equals to 0. And when you solve for x here, first thing we subtract 1. So when you subtract 1 on both sides, you get x squared minus 1. And then when you take the square root of it, you find out that you have a square root of -1. Does anyone remember what happens when you have a negative inside a square root? Anyone remember what you get when you have a negative?
Imaginary.
It's imaginary, it's
Imaginary.
I. Yes, you're correct. It's imaginary, it's I. So that means that if you have such case, the domain here will be all real numbers. So last time you should say all real numbers except 0, except 1/2, except 1, except 2. That's what you guys do, right? But what happens is when you solve this kind of denominator for your domain, if you solve it and you find out that your answer came up to be imaginary or I or something else, then that means every numbers will work in this case. I don't care, it's a positive or negative. So that's the reason why that they're all real numbers here. Okay, so since this domain is all real numbers, the domain of g of x is all real numbers except 0. So what is the domain in this case is we're going to take all real numbers except 0 in this case, because that one has an exception for it. So every time when you have all real numbers with all real numbers except something, we always take that domain in this case. Okay, so this is how you figure out the domain of a composition functions. So make sure you guys know what to do here because it's very important. Right? Let's do question 2 because question 1 is very straightforward. The only thing I want to point out in question 1 is B here is when you subtract F subtract G. This is the one that I told you about distributing the negative. So you have to take the negative and distribute to the 2 and the negative x. So a lot of students forget to distribute that. That is the problem here. Like D, when you factor it, since you factor this, when you divide this, these two are not factorable. So please do not cancel the 2 and the x here, then you get -5, you get it wrong. So leave it like this. And then the answer, and the question asking for domain for this. So the domain for this is all real numbers except 2, because when you put 2 here, you'll make him 0. Question 2 is a little bit hard because now you got a square root and a fraction. So when you add this, you just simply add this like this. Do not simplify for this case. If you try to simplify this, it will take you half a page to do it. So just leave it like this. Same thing when you subtract, you just subtract it. You do not simplify. Okay. When you multiply these two together. The only thing you can do is just chuck this on top, just combine this because this is over 1, right? The square of x squared minus 4 over 1, and then you just multiply square of x squared 4 over x squared times square of x squared minus over 4 or by x squared plus 1. A lot of students try to simplify this become x minus 2 because they say that x squared is a perfect square as x because you take the square root. 4 is a perfect square of 2. That is actually wrong. The reason why it is wrong is because of the subtraction here. So that's the reason why that you do not square root. You do not take a square root if they have addition or subtraction. If it's a multiplication, then yes, you get 2x. If you division, yes, you get x over 2. But for addition and subtraction, you cannot square root it. You cannot reduce it. And lastly, when you divide, so you take the f of, this is a bit more tough. You take the f of x, you divide with the g of x, the square root divided by the fraction. As you guys remember, when you divide something, you can change it to become multiply, but you have to flip-flop, right? So what happens here is I change division to multiply, and then I take the x squared over x squared plus 1, I flip-flop it, and then I just multiply these two together, become x squared plus 1 square of x squared minus 4 over by x squared. So the main part on this case is figure out the domain. The domain here is very, very difficult. Now, as you guys remember, this is x squared below here. So if you set it equals to 0 and try to solve for x to figure out the domain in this case is all real numbers except 0, right? Okay, all real number except 0. But you can also notice that on top here, you have a square root. So this square root on the top is very important. It's because it's telling us that it only takes positive number in here. Positive and 0. So what do I do here is you begin to plug in numbers in here and to figure out is what will make this negative. Because if you make it negative, it's no good. So if you plug in 0, 0 is no good because 0 minus 4 is negative. So 0 is no good. So we don't use 0 here. If you plug in 1, 1 is also no good. 2, 1 is no good. The reason why is because 1 squared minus 4 is negative 3. So that is also no good. Negative 1 is also no good because you also get 3. So these are no good numbers. So we do not want this kind of numbers in here because it doesn't work. But if you plug in 2 or 3 or 4, this work. Because 2 squared is 4, 4 minus 4 is 0. It works. 3, 9, 9 minus 4, 5 works. And same thing with the negative one, the negative 2, negative 3, negative 4. So all this will work. So in this case, your answer in this case will be from negative infinity to negative 2 because it works. And then it goes from 2 to infinity because the other ones work. So this is how you figure out the domain for this case. Although that is all real numbers except 0, which is already included in this domain because this domain is not included, doesn't have 0. Okay. But what happens if I say all real numbers except 5? Let's say you have this example. Then what you do is, so what we have is 2, 3, 4 works. But what happened is when you get 5, 5 does not work here. Although 5 squared minus 4 is nice, is positive, but unfortunately if you put 5, it will make him 0. So what happens if you have such case, then your answer will be negative infinity to negative 2, and then 2 to 5. So you will get 2 to 5, and then union 5 to infinity. So if you have such case, which is a bit more, then you got 3 domain here. One is from negative infinity to negative 2. One is from 2 to 5, and then the other one is 5 and above because those works. So so you have a multiple domains here. So you have to do the union in this case. You guys with me here? This is a bit tough when you guys do the division here. So that's why I have to spend a bit more time in this case. Okay. All right. Next, for this, you just simply plug in 0. So how do we do this is if I have f minus g0, you just do what is f0 is, and then you do g0 is, and then you subtract it. And don't forget, if you have double negative, you can change it to positive. Okay. What is fg negative 6t means that you plug 6t in f and you plug 6t in your g. So when you plug 6t, negative 6t in the f here, you will get negative 6t squared plus 1. That will give us 36t squared plus 1. And then when you plug negative 6t over here, you get negative 4. And then after that, you just 4 it out. And you will get your answer. Okay. So majority, if you see numbers inside, your answer will be a number or a fraction. If you see a variables inside, then you will have an expression. So like example, what we have here, they all have x in here, all the x. You find out that all your answers here are all in expression form, not in numbers. But once you put a number in there, like a 0 or 1 or 3 or whatever, then your answer is going to be a number like 5 or 1/3 and so on. Okay. Now we will talk about this dot product. So it's like kind of like putting to each other here. So I'm going to do question 8 because the domain is a special domain here. Okay, let's talk about, all right. So, this is quite easy because the domain here is all real numbers. If you have f dot g of x, it means that you plug g into x. So that means you can't use substitution. You plug 3 into the 5 minus x, And make sure that every time when you do this, you have to simplify it. Okay, so this is it. And since the domain for this is all real numbers, because it's a polynomial, and all the domain for g of x is all real numbers. So this is something I want to point out to you guys, that if your f domain is all real numbers, your g domain is all real numbers, then all the domain for the dot is all real numbers. And all real numbers means negative to positive infinity. So you find out that all this is all real numbers. Same thing with this question 7. When you have a cube root, the domain is also all real numbers. And then when you have an x cube, your domain is also all real numbers. So when you do this, all your domain is all real numbers. You do not need to figure it out. So this is what I can tell you for this. What is the meaning of g dot g of x? G dot g of x is like you putting the 5 minus x back into your x. So when you take 5 minus x, and this x will be replaced by 5 minus x here, because it's like a replacement. And then you just, like what we have here, and then when you distribute, you end up with an x here. Okay, so make sure you guys know what to do for question 6, 7. 8 is a bit tough because of an absolute value. So when you do f dot g of x, means you plug all this into your g of x. So, so you will get absolute value of 3 minus x minus 4. So this will give us negative 1 minus x. Okay, you just combine like terms and put in absolute value. G dot f of x means you take all this f of x and substitute into your x. So you get 3 minus absolute value of x minus 4. The domain here should be also all real numbers. Sorry, this is wrong domain. The domain here should be all real. The reason why the domain here is all real is because the domain for absolute value is all real. The domain of polynomial is also all real numbers. So the domain for this case will be all real numbers. And you cannot combine these two because one is inside the absolute value, one is outside absolute value. G dot g of x means you plug 3 minus x, and the x will turn to become 3 minus x. And when you do this, your 3 will cancel out, so you get an x, and your domain here is all real numbers too. Is anyone doing okay so far with this composition function? Anyone have any questions with this? The next one is we have to give you, last time I give you 2 functions and you give me the dot products. This time I do the opposite. I give you the dot products, you have to give me the 2 functions. So how do we do this? It's very easy. First, to figure out which dot which first. So if you look at this, that means f dot g, that means g has to become first, because it's the last one. So what happened is that, how do we do this is we just look at your question 11 here, is you look at it. So the one inside here, inside the square root or inside the square or inside the cube root, whatever, is always goes first. And in this case, g. So that's why when you have, when you do this, your g of x will be 2x plus 1 first. And then after that, you replace the 2x plus 1 with x. So you got x squared for your f of x. So this is how we do it, is to figure out which one come inside, and inside always to come first. And g is the one that comes first. So g of x will be that one, and then you square it. For this case, I will use the square root of 5x plus 2. That will come first, and that I put in g. So in this case, the square root of 5x plus 2 will be the g. And then I'll replace all those into x, and I put it in f. So this is what your f of x, how we do it backwards. So it's not that difficult actually. Next one is a word problem. This is a bit, 14 is the last one. So this is n is a number of bacteria found in a food, in a refrigerator, given us by 10t squared minus 20t plus 600. Don't forget these t are all caps. T in this case is between 2 to 20, and T is the temperature of the food. So this is calculate how many the bacteria grow in this case. Okay. When the food is removed out from the fridge, the temperature TT is given us by 3t plus 2. Again, this T is a lower case t, where this T is time in hours. It's between 0 and 6. So the question is find the composition of NTT. So when you see NTT means that I plug this T into your N. So I plug this inside this T. So I got 10, 3T plus 2 squared minus 20, 3T plus 2 plus 600. And what do I do here is I have to void the 3T plus 2 first before you multiply by 10. So when you void it, it's 9T squared plus 12T plus 4. And then you multiply this by 10. So you get 90T squared plus 120T plus 40T. And then you distribute the negative 20 here. So you will get negative 60T minus 40 and then plus 600. And then what you notice is the 40 and 40 can cancel. You combine like terms. So you got this 90T squared plus 60 plus 600. So this is the NTT that we find. And what is this NTT means? This is actually is N, the number of bacteria over time. Because this T, the little t here now is time. This NT, the capital T, is actually the number of bacteria based on temperature. And this new function that you find NTT is going to be a number of bacteria based on time. So this T is time, this capital T is temperature. And then the next one is find the bacteria after half hour. So you just substitute your T to become 0.5 on this new equation you find, and you get your answer here. And then next, find the time for bacteria reach 1500. So now you just plug NTT to become 1500, and you try to solve for T here. So I need to subtract it to become 0. So 600 take away 1500 is 900. And then I'm going to divide, I'm going to cancel one of 0 and divide by 3. I'm going to simplify this before I use my quadratic. So I get 3T squared plus 2T minus 30. And then I use quadratic formula here to figure out my T here. And don't forget that when you use the quadratic formula, which is, I think you have to do the quadratic formula, you find out that the negative, you can ignore it because we can't have negative because it can't have negative time. Okay, so that's the reason why that when you guys do this kind of homework, I only take the positive. So it's negative 2 plus 19.07, which is the square of 364 over 6. The negative is ignored because you cannot have a negative time in this case. So this is how we figure out your composition functions in this case. And yes, when you do your homework, the last question of your homework will look something like this, the number of bacteria in this case. So anyone have any questions here before I move on to 2.7, which is inverse function, which is important. Anyone have any questions for me? And again, if you do, just let me know and I can, after class, we'll talk about it. So the last section on chapter 2 is inverse function. So what is the inverse function? By definition, inverse functions say that if you do f dot g and g dot f, you get exactly x. Exactly. No x plus 1, not 2x, not x squared, exactly x. So if you get this, then you get yourself an inverse function. Okay. Inverse function is written down by f minus 1. Okay, so usually we use that, and usually we do f minus 1x. So usually put an x on it to make it as an inverse function. So this is something very important about inverse function that you guys need to know is the next one over here. Okay, where's my highlight? There you go. The domain of f is equals to the range of the inverse function. The range of the original function is the same as the domain of f, the inverse function. So what I'm telling you here is if you know your domain and range of your original function, what you do with the inverse function is you just flip it. So the domain is the same thing as the range. The range is the same thing as the domain. So that's why this is very, very important. So if you know one of the domain and range of one function, you will automatically know the domain and range of the other function. You just flip-flop it. Now, this is how we do it using function. Sometimes graph also can be used to figure out functions. It's very easy. It's your coordinates. If you have a point AB on the f function, and if you flip it, BA is also going to be on the inverse function. So it's very easy to figure out. Let's say that f has a coordinates of 5, 6. The inverse function will have the coordinates of 6, 5. Okay, and so on. And another way, if you have graph, is you can do a reflections on y equals to x. So for example, is this line is y equals to x. You find out that these two graphs has a they are the same, they are inverse to each other because their reflections are the same. So this is actually is x squared, and this is actually is square root of x. Okay, and I will tell you why that your x, usually x squared is a parabola, you know. Why this x squared only take half of the parabola? Because of this. Okay, so in order for us to have an inverse function, you have to do a one-on-one. The function has to be one-on-one. And how do we do one-on-one? You have to do a horizontal line test. What is horizontal line test? Is only one point can be crossed over on the horizontal line. If there is more than one point, then it is not an inverse function. For example, a square root of x passed the horizontal line test because every horizontal line you draw, it crosses. Okay. Next thing is the square root, the x squared. The x squared is not doesn't pass the horizontal line test because when you draw the horizontal line, it crosses 2 points. So what we do is we have to restrict the domain. And what's the meaning of a restrict the domain? Means we take half of it. So we cut this into half. So this will pass the horizontal line test. So when you guys look at the x squared that I have, you will see this x squared minus x squared greater than 0. So this x squared greater than 0 is actually is what we call as the domain restriction. So the domain restriction here is to telling us that if you have this domain restriction, that will make the line one to one. And once you make it 1 to 1, then this will have an inverse function. Because if you take the whole parabola, then this do not have an inverse function. But if you restrict the domain, it will be. Same thing with absolute value. Because absolute value, the graph is a V shape, and you have to restrict the domain by half. And do not forget that if you take this half, your x squared is positive. So this is a positive side. So that's why your square root is going to be positive. Okay. But what happens if you take the negative side? Then your inverse will have a negative square root. So that's the reason why that you have to be careful with what side do you pick. If you pick the negative side, which is going the other way, then your inverse function for square root is going to be negative. So we'll talk more about this domain restriction. Okay, so this is, if it's 1 to 1, then you can say that it has an inverse function. So make sure that this is very important for some restriction. So how do you find inverse function algebraically? So out of all this, I will put checkpoints so you know that which one is important here. This is very important, the range and the domain for the function. This is important, the one that finds the inverse function algebraically. Okay, and the first thing is you have to check, you have to see whether the function is inverse by doing a horizontal line test. If it does not pass the horizontal line test, it doesn't have inverse function. Did not pass horizontal line test, no inverse function. And you will skip the rest of it. You're done. So if you did not pass the horizontal line test, no inverse function, you're done. So for example is, if I just give you x squared, this one has no inverse function. because of it does not pass a horizontal line test because it's a whole parabola. So you're done. But what happens if I say x squared, x is greater than 0, then this will pass the horizontal line test. Because it will be this one, the one we just talked about. And then what you do next is you have to, first thing is replace your f of x become y. So usually this is f of x equals to that. So what you need to do here is you have to change this f of x become y equals to x squared. So that is the next step you do, second step. Third step is interchange x and y. So the third step is to change all the y to become x and all the x to become y, and you have to solve for y. That is your that is the third step. So when you solve for y, you have to take the square root. And every time when you take the square root, you have to have the plus minus. So that's the reason why that you got two types, plus square root of x and minus square root of x. So which one do you take? Depends on, are you taking the positive side or the negative side? Since you give me x, you're doing your restriction domain of x greater than 0, we take the positive side in this case due to the x greater than 0. So the negative in this case can be ignored. So in this case, your inverse function for this is y equals to square root of x. But then the last thing is replace the y by the f inverse. So a lot of students in the test, they just put y equals to square root of x. You get it wrong. You have to put it y inverse. Change your y to the inverse function. But what happens if you change this domain to become negative? Then we will do the negative side. So then your answer will be just, the inverse function will be just a negative square root of x. So that's the only difference between which one you pick, a positive or negative. It depends on the domain restriction. And some students will ask me was like, so can I use negative? My answer is yes, you can use a negative one, then you have to give me the negative answer. If you use a positive one, you use a positive answer. But if you give me a positive one, you give me a negative square root, I will mark you wrong. Sometimes in your online homework, they will tell you that I only want to use a negative one. So you have to use a negative one. You cannot switch to positive one. Okay. You guys all right with the inverse function here, which is really a lot of work here. It's not easy. Question 1 is very easy because they give you the coordinates. This is x. Don't forget, this is y. So if you want to find the inverse function, it's very easy. You just flip-flop all your coordinates. So, so like this -2, -2, your inverse function is -2, -2. -1, 0 becomes 0, -1. So what you do is you just flip-flop all your coordinates, and that's how you find your inverse function. Okay, so it's very straightforward type if you have a coordinates. Question 2 is asking us how do we do it algebraically and graphically. So how do we know is these two functions is inverse is you do the dot. So when you do the f dot g, you get exactly x, and when you do g dot f, you get exactly x. So when you do f dot g means you plug all this g into the f. So that means you get 3 minus parentheses 3 minus 4x over 4, and when you simplify this, the 3 cancel out, the 4 cancel out, you get x. And when you do the g dot f of x, means you take the f and plug it back into the x here. So you get 3 minus 4 times 3 or minus x over 4. Again, the 4 will cancel. And then when you distribute the negative, the 3 will cancel. You end up with x. So this is how we prove these two functions are inverse algebraically. How do we do these two functions graphically? Is you graph these two out. So for this 3 minus x over 4, I just want to point out to you that 3 minus x over 4 for f of x can be written down as, I can split that 4 into 2. 3 over 4 and minus x over 4. So I can split this 4 into 2. So that means that my y-intercept is at 0, 3, 4, which is 3/4. And then I have to go using rise overrun. I go down 1 and then go over 4. So this line is your f of x. For g of x, your y-intercept is 3, but your slope is -4/1. So I go down 4/1. So you find out that these two lines will cross at one point. But when you draw the y equals to x, you notice this is the line, the dashed line that you see is a y equals to x. You notice that these 2 points, these 2 lines will coincide. That means this line is a reflection of him, of this f of x, and this g of x over here is a reflection of this. So sorry. This will reflect here, and this will reflect that. Sorry about that. So this whole line will reflect it on him. So this is how you figure out graphically. So in your online homework, you do need to draw 3 lines. One line is this straight line, f of x, and one line is a g of x, and one line is a y equals to x. I will show you how to do it online on your online homework here. Next, we had to figure out if this function is 1 to 1. How do we figure out this function is, it has an inverse function, it has to be 1-on-1. And how do we figure out if there's 1-on-1? You cannot share the y values. So what do you mean by you cannot share the y values? You find out that 1's been shared twice, -2 is been shared twice. So this is not inverse function. Okay, the reason why it's not inverse function is because they share the same y value. Okay, so if I give you graph, you just draw a horizontal line. So question 5 is not a function because it failed. Question 6, it has an inverse function because it passes a horizontal line test. Okay, so if I give you a graph, you just draw a horizontal line to figure inverse function. This is the one that we talk about for the checkpoint I showed it to you early on about how do we change inverse function algebraically. So using the interchange. So first find the inverse function for this. So this one has a domain restriction because x squared by itself doesn't pass the horizontal line. So once you have this, it has a domain restriction. So make sure that this is less than 0, means that, remember last time we took a positive, now you have to take a negative and you take a square root. So what I do is I change the f of x to become y, and then I interchange your x and y, become x and y, and then I solve for y. So I add 2 over here, and then I take a square root, and then I do the plus minus. Because this is a negative, I take the negative side. So this is, then you change the y to become inverse function. So this is negative square root of x plus 2. And then graph this, both of them. So x squared minus 2, if you remember your transformation, x squared is a parabola. Minus 2 means you go down. So, so you got x squared here, you go down 2, because the minus 2 means you go down. And you notice that usually the parabola is a whole parabola like this, but I only take this side is because the domain says I only take negative side. And then if you look at this, this is a square root side. A plus 2 in this case means you move left 2. And this negative means you do the reflection on the x-axis. So what happened is that the original graph of this is a square root graph. It looks something like this, square root. So what you need to do in this square root graph is you have to move left 2 first. So you move left 2. So this is what happens. And then after that, you have to reflect this on the x-axis. So this is what happens to that. So these two graphs, if you draw the y equals to x graph here, you'll notice that they are inverse to each other. Okay. And then you need to find the domain, describe the relation. The relation is very easy. You just say it's reflected on y equals to x. So question C, if they ask you for the relationship, the answer is always reflected on y equals to x. And then you find the domain and range of your f and the inverse. As I told you, if you know the inverse, the domain and range of the original function, you just flip it, and that's how you find the domain and range of the inverse function. So how do we figure out the domain of your original function? Because of the domain restriction, your domain is from -infinity to 0 with the brackets, because there is an equal to sign here. And your range is from 2 to infinity, -2 to infinity and brackets. So what happens to your inverse function? You just flip it. So the domain, if you want, you can look at this black ink point. Is -2 to infinity included, and for the range is -infinity to 0, which is exactly completely flip-flop here. Okay, so that's the reason why I told you that if you even doesn't need a graph, you can still figure out this by flip-flopping it. Okay, I will do one example later on. Most of the rest is pretty much straightforward. Let me do some example in the homework so you guys can see what's going on. So we're gonna do 2.7. Let's do 2.7. 2.7. Okay, let's do the graph one because we need to talk about the graph. You guys see this one, right? 2.7, number 14. So use this graph to find f minus g2. So f minus g2. So how do we do f minus g2 in this case? Is you figure out what is f2 is, and then you figure out what is g2 is, and then you minus it. Okay, this. So it's not that tough.
Isn't this 2.6?
This is 2.6. Yeah, I'll do a bit of 2.6 and then I'll do more on 2.7. So f2, if you look at this graph, f2 is the y value. So f2 in this case is 0. So f2 in this case is 0. And g2, this is a g function. g2 in this case is 2. So 0 minus 2 is -2. So this will be -2 in this case. Okay. So this is pretty straightforward type for this because this one you just need to figure out what f1 is and what g1 is, and then you multiply it. And then we'll talk about the dot products, f dot g1. So how do we do f dot g1? First thing is you do the g1 first because the g is the very end of this dot product. So you do the g1. So g1 in this case give you 3. This is g1. So the y value for g1 is 3. So what happens with this 3, you put it back into your f. So whatever you get the output on here, you put into the f3. So f3, this is f3. f3 in this case is 2. So your answer in this case will be 2. You guys see what I'm trying to do here with this? I know this is 2.6. This is how we do the dot product here. So make sure you guys know how, by reading the graph, okay? I will do 2.7 now, so you guys can see what's going on with 2.7 here. Yep, 2.7. So this is, we're gonna do some inverse function. That is a bit more difficult. Before I start doing, I want you guys to go ahead to type in present for attendance. You guys know what to do here. So go ahead and type in present for your attendance in the chat room. You guys with me? Yep, thank you. Yep, got you. Go ahead and do it. This one is a really, so I want to see the one that's almost all done for you. Oh, it's all done. Oh, and they're all done for you already. So you do not need to graph it. Okay, then we'll do a few more of this. So let's do one that is very difficult. Where was that? Sorry, I'm looking for a tough one to do. Yep, this one. Let's do this one. You have to find set question 13. FGX is FGX. So this wants you to put in this g of x. So you just need to copy this. I hope it works, and paste it. Nope, doesn't work that way. Doesn't like it. Nope. 3x over 4. I'm going to do division here. Gosh, actually more. 3x over 4, 3x plus 4 over by x minus 1. So this is what you have to type in here. And then what happens is then you have to take all this and plug it into your x. So this, copy this. Oh, they don't like copy, huh? Okay, then you have to retype it, sorry. So you have to type this multiple times. 3x plus 4 over by x minus 1. And then same thing in down here. So what this tried to do is you take this 3x plus 4 and plug into your x over here. So you get 3x plus 4 over x minus 1. Okay. Same thing happens to this, but this time you don't use the g of x, you do the f of x. So you have to do x plus 4 over by x minus 3. And then the rest follow the same. X plus 4 over x minus 3, x plus 4, x minus 3. How do we graph this? So in order for you to graph this one, they will say that you got y equals, the g is the blue line, the f is the black line. So don't forget the f of x here is x minus 3, right? So if you remember that the domain for this f of x, anyone know what's the domain for the f of x here? Anyone? It's a fraction. We just did it in the beginning of the class. Domain is all real numbers except what? Except this one. This is f of x. All real numbers except what? Domain. Anyone? This is all real numbers except 3. Yeah. So we know the domain here is all real numbers except 3. So what happened is you look at your line and your line has to be at 3. So most like this one is at 3. So all the black one has 3 on it. So see, they don't cross at 3. 1, 2, 3. So the black line all shows exactly the same. Maybe this one is a little bit off. Then we do this. What is the g of x? All real numbers except what? G of x. The domain is all real numbers except, anyone for g of x? This is also easy. 1, yes. So what happens here is you cannot, the blue line cannot cross at 1. So they all have the same, almost the same thing, right? They all look the same. But the main part of this question is asking you for range. Yes, this is the one that a lot of students doesn't know how to get it. So does anyone know what is the range of this f of x? Now, you know already these two functions are inverse. And what do I tell you about the range of the function, the f of x? The range of the function is exactly the same as what? The domain of your g of x. So in this case, the range in this case will be all real numbers except 1. And what is the range for your g of x? Is all real numbers except 3. So now you can look at your range. So your range here, this is very difficult to see here. Yeah. Your f of x, this is f of x. So this one is wrong. The reason why this one is, let me see, this one might be correct. Let me see which. This is hard to see from both sides here. Domain is, let's see the black one. This is 1. This is 1. So let's do the range is 3. 3. Why they all look the same to me? Oh, by the way, I can tell the answer without doing this. Your answer is this one. Does anyone know why the answer is this top right one? Yeah, you didn't actually, you don't need to do all those work, but I can tell you this is the right answer. Why? Anyone know why? Because they intercept. I can tell you that your y equals to x is always intercept at those 2 points that they always intercept. You see this? This 2 interception is not on the y equals to x line. This one is totally wrong. This one, the 2 intercept, You see that? It's not on the y equals to x. So how do we figure out if we have this is usually the interception of the inverse functions will intercept at y equals to x. So that's why this below is the correct answer. Okay. All right, let's do another one. Submit later on. Yep, this should be the correct one. Yeah, I didn't finish that. This is correct. Let's do the next one, the one that I really need to do. I cannot find it. Where was that? The rest is mostly, don't forget the domain and range, flip around, domain, this one, question 25. So pay attention on this because it's gonna be in your text. Now I can get your attention. So the first thing is asking, is this function has an inverse function? So what is going on with the inverse function? It has to be one-on-one. And how do we figure out if it has a one-on-one? One-on-one means that if you plug x one number, you get y one number. So we can always check it. So when you plug x to become 1, you will get y, you will get 3 minus 5, which is -2. And 4 plus 3 is 7, which is you got one answer. So that's good. And you have to do the opposite now. So now you plug y become any number, let's say 0, make things easy. So when you put y or f of x becomes 0, so this will become 0 over by 3x minus 5 divided by 4x plus 3. And when you multiply 4x plus 3 on both sides, you notice that when you multiply that with a 0, you notice what happened is the whole thing will become 0. So what you get here is just this will cancel out, this will become 0. So you get 0 equals to 3x minus 5. So when you solve for x in this case is 5 over 3, which is also one answer. So this is how you prove that this is one-on-one. So this is how you prove if you want to figure out without a graph, you plug x, figure out y, got one answer, and then you plug y, and then you got x one answer. It do not need to be exactly the same answer. We just need to have one answer. So this is a yes, this is a one-to-one. And then the next thing we're gonna do is to find the inverse. So remember last time when you find the inverse, you have to change the f of x to become y, and then you interchange your x and y. So that means your f of x become x, your 3x become 3y, minus 5 divided by 4y plus 3. So now we have to solve for y. Now this is where the difficult part. So please pay attention here. So how do we solve for y here is we multiply 4y plus 3 on both sides. Okay, we will multiply it. So in this case, you will get x times 4y plus 3 equals to 3y minus 5. And this 4y plus 3 is gone because it will be multiplied to that. And then you distribute your x. Okay, distribute it. So you got 4xy plus 3x equals to 3y minus 5. Now this is the part that you guys have to, a lot of students fail, not fail, do not do well in this question is because they doesn't know what to do next here. So what you need to do next here is you combine all the y terms on one side and the rest on the other. So what I'm talking about here is I will move this 3y to the left side, and I will move the 3x, the non-y term, to the right side. So I still get 4xy, and when I move the positive 3y, it becomes negative 3y. And then when I move the 3x, it becomes negative 3x. Okay, so what happens here is that my 3x will become negative because I move it over, and my 3y will become negative because I move it over. Okay, Next, this is also difficult. Now you notice that this left side has all y terms. You have to factor the y out. Okay, you have to factor it out. So when you factor the y out, you will get 4x minus 3. And then you got negative 3x minus 5. And then after that, you divide it off. So in this case, your answer will be the inverse function. Don't forget the inverse function is negative 3x minus 5 divided by 4x minus 3. So this is how you key in, this is how you do your answer in this case, and this is your final answer. So your answer in this case is negative 3x, fraction first, negative 3x minus 5. And what happens to my denominator? What do I have in my denominator? 4x minus 3. So this is how we do this question on 25 if you see something like this. So make sure you guys got what your answer here. Again, this kind like question 26, the reason why this is not 0 is because of domain restriction. Yes, question.
Can we just flip that original equation to negative value, or
oh no. This is some people will do. Oh, this is like putting negative value. The answer in this case is no. Is that Elijah? Or so no, it's not as simple as flipping negative sign or anything. This is the only way to do the find the inverse function here. It's not simple as just flipping the negative sign. I can tell you it's not true. Okay, so some people will say, oh, I just put a negative here and change the plus to become negative. The answer is it's not going to work out. So be careful with that. So a lot of students do that in the test, and that's why they got it wrong. So make sure you have to do it the way that I showed to you just now. That is the correct way to do it. Okay. All right, so that's it for today. So don't forget you have 3 homework due on this coming Monday, 2.5, 2.6, and 2.7. So I'm going to stop recording here. So make sure that you guys, if those students who forget to put in the